First Spin. Welcome to First Spin, a show where I learn how to use the parallax propeller without having any prior programming experience. And rather than do this by myself, I have enlisted the help of two experts.
Yep.
Oh, yup.
Yep.
Yep.
So, like, I'm Whisker, and that's Roy Eltham.
No, this isn't Roy.
No?
Oh, wait. Yeah, it is.
Okay.
Everybody's
At least
having
we've
an
got
identity
that
crisis
down.
today.
Yeah.
But what I will say is that this week, we should not have to record 3 times in a row.
Hopefully not.
Yeah. We were fortunate enough to get another audio interface quickly and finagle some free shipping.
It cost me $400 still, but I love all of you very much, obviously.
Right.
Yeah, you all need to buy me nice birthday presents this year.
Right.
Or just donate on the donate page.
Sure.
Yeah, that works too.
That works too.
A few people have done that.
It's true. And we wanted to thank all of our supporters who have donated either because of hearing, of finding us through First Spin, or just in general because you're awesome. We super appreciate it. We thank you for your support. And we thank you for listening and for giving us feedback on what all we need to do.
Yep, we're really dedicated here. We're not going to let stuff like this get in our way. So, as soon as it broke, I ordered a new one. Eddie managed to get free shipping on it. Next day, free shipping, which was nice.
Awesome.
And within a couple of days, the community came together and got 120 of the $400 back already.
Yeah.
So that's nice.
Thank you guys very much.
Cool.
Yep. So we are going to continue on our module extravaganza. We have thus far gone through
several of the modules.
Correct. We have
I
always
list
love
them all out.
No, but I love doing this because it means that we've gone through them. Like that I am now a quasi expert in.
So eventually our show will just be listing out every module we've covered.
Heck
and we'll have
yeah.
5 minutes to cover the new module.
Sweet. When it gets to that point, I will have succeeded. So 5-point switch. We've done the ping, a 5-position switch, the ping sensor, the RC servo, the GPS module. Yep. And then this week we are going to do the compass module. Yep.
3-axis HMC 5883L compass module.
There'll be a bunch of links about it in the description of the show, I'm sure.
Yes.
Oh, yeah.
So, as always, I'm going to first direct everybody to the learn.parallax.com website /kickstart. This is, again, where they have all sorts of pages for all the different modules, doing a little introduction, giving you a little introductory code, and showing you, like, wiring diagrams.
For different modules and stuff, yeah.
Correct. So this particular module, or the compass module, the 3-axis compass module, it can measure the Earth's magnetic field in 3 axes. So X, Y, Z.
It can also freak the heck out if you put a magnet close to it, which is kind of fun too.
That's true.
Which includes things like motors.
Yep.
Motors.
There's magnets in there.
Eddie was working with this
that explains it.
the week, and I was taking a Phillips screwdriver that happened to be magnetized, Stanley, and I was putting it close to her compass when she was looking at her debug window, and I was going crazy, and she's like, what? Is there a bug here? I'm like, he.
And that explains it, because I know that when I was putting the compass module near the RC servo, it would start at 180 degrees, it'd start be like, meh, 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 and start just repeating itself and not moving on. So I had to add some error margining. Yeah. So that explains it.
A little bit of distance. A lot of people, if you see little robots with compass modules on them, they have a little stick sticking up 6 inches and a compass module mounted to the top of the stick, and then the wires going down to the board and the car to keep the compass module away from all the electronic fields and batteries and motors and whatnot.
So about how far do you have to?
Magnetic
Keep it.
periscope. I like it.
that's
It
cool.
depends, but usually a few inches is good enough.
Oh man. So mine is currently only about an inch away from the
Well, from the gearbox, you're
from the
probably 2
gearbox.
inches away from the actual motor.
I see.
Right. But if you put like a little bit of a spacer, a couple inch spacer in there, it'd probably help improve its performance a little bit.
My owl will become a giraffe with a 2-inch neck.
So you've been working with this compass module.
Yep.
I assume you have questions about it, or we wouldn't be here.
Of course. Well, like with all the other modules, I thought it'd be a good idea just to go through first the hardware and then go into a couple of examples of the code. And the code is a bit more complex than what I am actually concerned about learning, which is kind of a surprise.
I was hoping she wouldn't have any questions. Then we could just end and be done. And I could go do something else tonight.
Roy, first spin is the thing to do. What are you talking about? So,
well, you have questions, so
right.
we're here.
Right. You're
I
bound
really
by your
enjoy
expert.
multiplying my productivity. I could be sitting there being productive on my own. Instead, I'm going to sit here being productive, answering Addie's questions, which may help many other people be productive, therefore multiplying my
Teaching
productivity.
teaching fish to men. Teaching men to fish or to use compass modules. And women and children.
Okay.
Huzzah. Okay, so let's take a look at the hardware. It's a very cute little 1/2 inch by 1/2 inch module, and it has 5 pins on it. It has ground, it has VN, DR, DY, SCL, and SDA. So ground we know, VIN we know, and this I believe runs on. I want to say 3.3 or 5 is fine.
It actually can work on anything from 2.7 to 6.5 volts.
Even better. So it's got a wider
Has
range.
built-in voltage regulator to regulate the power to what it needs.
Very interesting.
Yep.
Okay, so we know those. I know the SCL SDA, that's the serial clock, serial data line for the I2C. The DRDY, that I don't know.
It's short for data ready.
Okay.
And in this particular package, it will be, at least I believe, held high. And then when there's data ready, it will go low for a short period and then go back high again. And that just means that if you wanted to, you could have your cog that's reading it wait for the data ready pin to go low.
Mm-hmm.
And then wake up and read the data out of the compass and then go back to sleep, go back into the wait loop, which causes it to go into low power mode.
And let's be honest here, this is mostly a feature for chips other than the propeller that can't do 8 things at the same time.
Oh,
It would be very useful for when you're dealing with interrupts or something like that. You don't want to have to be dealing with the I squared C all the time.
Right. The other thing, though, is that the compass is only going to give you information at some, it's like 100 megahertz rate or something, or 400. It's not at a continuous rate. Like if you read it continuously at full speed, you'll get the same values several times in a row because it hasn't updated yet.
Mm-hmm.
And then it'll update and you'll get a different value.
And I imagine that's exactly what Eddie's doing right now, is just brute force reading it constantly.
Yep.
Right. And if you're reading it in spin, you're reading it at a slow enough rate that it's probably giving you new data each time. But if you had some PASM code reading it, you could use the data ready pin and make it go use less power because it would go into a low power mode most of the time and only wake up to read it when it needed to read it.
I see. So for battery conservation or something like that.
Right.
Yeah. Kind of like how I did with the podcast clock. If you guys want information on that, it was Parallax Project of the Week several months ago. I used a whole bunch of the fancy tricks to make the sucker take almost no power unless you actually wanted it to be actively doing something.
Mm-hmm.
Right.
Now, can I ask, what Well, yeah. What projects have you guys worked on that would require magnetic, like a compass information or compass data?
Well, one that comes to mind for me is that I'm going to be using the same trick that uses to figure out the rotation left or right of my big robotic camera jib. I'm going to have essentially a one-axis compass module. That one's 3, but having a one-axis compass module sitting right next to a magnet so that it's got a very strong polar field there.
Okay.
So as the shaft rotates against that, that sensor, it's rotating the magnet.
Mm-hmm.
And then I'm taking that as my feedback loop for my, dead reckoning, right?
Sure.
And I'm sure Roy has probably used the compass module with little bobots and whatnot.
Yeah, I've had at one time or another used a compass on 3 different robots to do basic navigation. Never done anything super sophisticated yet.
Mm-hmm.
But just like, go north for a few feet and then go west for a few feet, that kind of thing, and have it turn.
Is there one on your quadcopter?
No. My quadcopter just has the standard hoverfly board right now. I'm still working on my own custom board with all the sensors, but I will eventually have a compass, an accelerometer, a gyroscope, a GPS.
Yeah, you combine those together and you've got some pretty
Yeah.
pretty good placement in 3D space there.
Right. And then also with the GPS and an altimeter, you can do pretty good navigation around.
Now, essentially what Addie's using it for is as a feedback loop to know where she's rotated to on a servo so that she knows which degree from north she's aiming her ping sensor.
Mm-hmm.
So that she can pull
so every 5 degrees or something.
a perimeter of distance from a center point, and she can measure out how many degrees she's rotated for each point that she wants to rotate to and ping out.
Correct.
Yeah, Parallax has something like this. Their little ping servo mount kit for the Bobot.
I did see that. Yep.
Has an optional extra mounting on the top of it for putting on one of their older compass modules, which was just a old. I forget. I don't know if they have it anymore. This new one replaces it, but they had a similar kind of thing where they would use it to aim the ping, or also to just figure out which direction the Bobot was facing.
Mm-hmm.
So either way.
Gotcha. And I think I saw something like that. It was like a ping chassis or something. And it even had code with it, but it was for the basic stamp. And so at first I was like, oh man, like I could have just like used that code instead of written my own. But crap, it's like on basic stamp, so never mind.
Yeah, you're not up to the level where you could port things yet.
Yeah,
eventually.
Well, she made her own version from scratch, so I think she's heading in the right direction.
Kinda, with a lot of help.
Well,
a lot of grapes.
From scratch, but using a lot of already existing code.
Right.
Sort of.
I made it modular, so.
Yeah.
But, okay, so on to the code. We'll start with a Kickstart code. As always, you just go down and you download the little zip package that they have. And the spin file that we're going to be looking at right now is the compass-propeller.spin file. So we're probably going to skip through most of the things that we already know. I'll just touch on
stuff.
Right, touch on a couple things. So in the object section, the one new thing is the SL32 in engine. We're not actually going to go through that.
Hold on, you're looking at the wrong source file because that's the other one.
Is it?
Yeah, the one on the
Kickstart
page. No, the one on the Kickstart page just has full duplex serial as the only object.
Oh,
and it does just the raw XYZ reading.
Well, this is awfully confusing. Okay, well, I'll put a link to the Kickstart page.
Were you looking at the one that you've modified?
No, this one is one that I downloaded from.
Yeah, on the product page, on Parallax's product page for the Compass model, they have another demo that's a little more sophisticated than the Kickstart.
Right. Okay,
that's where she started going. We'll cover that one in a little bit.
Okay. Is it also called compass.propeller?
No.
It's
called-
HMC 5883.
Yeah.
Yeah, okay. All right, I got it. I'm on top of it. Okay, so we know the object. We've worked with that before. We know the con section. Although this time, instead of xInFreq, it's using clock freak.
Yeah.
And now
it doesn't really matter.
It doesn't
either.
really matter.
You can
it's
either
just-
put xInFreq with the 5 megahertz crystal, or you can put in clock frequency with the end result clock speed, and it will figure out xInFreq.
Okay, all right. Easy enough.
You can do it either way.
Right. Now, the one thing that is new is this write data, read data mode, output x MSB.
What these are is the byte commands for the I2C protocol to talk to the compass. So those are the bytes that it responds to for reading and writing data, and mode and output XMSB is just one of the registers that you want to set it to read.
So this is something that you would find on, say, the data sheet of the chip?
Yeah.
Okay.
Well, it's some of it is just the I2C protocol, and some of it is the particular module you're talking to. The data sheet will tell you the bytes.
Now, is MSB there shorthand for most significant bit?
Yeah.
Most significant bit. Oh.
Oftentimes you'll see MSB or LSB as shorthand for most significant or least significant bit.
I see.
It's very common short form.
I see. Okay.
Right.
And then
so it's setting it, that particular one is what register has the beginning of the X data, right? For the XY. And they're in order. So it ends up setting for the X MSB, and then it reads multiple times and it gets the X, Y, and Z one after another.
Gotcha. Okay. And you only have to put, I know this sounds stupid, but you only have to put the ones that your code ends up using, right?
Right.
Okay. All right. Okay, and then we go through variable section. Some global variables are made. Pub main, we are waiting. Then we're starting the terminal. And then we come to set cont. And normally
That's
I'd see
short for set continuous.
Right. And normally I would see this like as if these functions that were being called were in an object somewhere, but in this particular program, they're all in this program.
They just included all of the stuff you need right in the same module of code. So set cont is right there, and it's short for set continuous, and it's calling start, send, and stop, and those are, again, later on in this file, and those are the I2C protocol commands.
Okay.
So that's all they're doing, is they're just doing the I2C on the particular clock and data pins.
Gotcha.
And then
oh, go ahead.
And so it's, in that particular function, it's setting to do the write data mode, and then the mode, which is a register inside the compass, to set its mode. And then they just put a 0 there, which means put it into continuous output mode. And so that's all they're doing in that function, is telling the compass, hey, start outputting your data, and just keep doing it forever.
Oh, I see. Okay.
Right. It's just setting the compass up to say, do your thing.
Right. Gotcha. Okay, and then we go to the repeat loop, set pointer, output XMSB.
Right.
So
again, that's really similar to the set continuous, except that they give you a parameter there, which is the register that you're going to set the pointer to, and all they're doing there is sending out the I2C command to set up where to start reading from.
Okay.
Right? Tell the compass, when I read the data from you next, start at this point in the registers inside of yourself. So if you'll notice, up in the repeat loop, we set the pointer, and then we call get raw.
Yeah.
And get raw is going to send some more I2C commands to read data out of the compass.
Mm-hmm.
And it's going to read the X, Z, and Y values out.
Mm-hmm.
And so what the set pointer command is doing is telling the compass
where to start from.
To start from when I read next. Here's where I see. Start sending me the data from.
So it's like saying, okay, go to page 1, class. Now let's read.
And then it's yeah.
Okay, gotcha.
And then again, get raw is just reading out the bytes.
Right.
And there's 2 bytes per value. That's why the MSB was there, is that it's the most significant bits are in the first byte. And then it reads the next byte, and that's the lowest LSB, the least significant bits.
Okay.
For the X. So there's 2 bytes for X, and then 2 bytes for Z, and then 2 bytes for Y. And they do it in that order in this particular compass module.
And how do you know there are 2 bytes? I'm not. Truthfully, I'm not overly concerned about it because I don't think it'll.
The data sheet for the compass will tell you, like, this is the way the registers are laid out inside this compass, and for this particular one, you have 16 bits of data per axis.
Okay.
Right. So you read, and with I2C, you always read a byte at a time.
Okay.
So the registers are 1 byte in size, so you just read the bytes one at a time.
Okay. Gotcha.
And combine them together down in that get raw function. You can see it doing the shift up by 8 and then ORing it together to create a single value for each of them.
Okay. I will nod my head. Truthfully, I would normally say...
Would you say, Roy, 8? 8 at a time, 8 bits at a time?
Yeah, it reads in
so
a byte
it reads
at a
in
time.
8 bits, and then it bit shifts them over, and then it reads the next 8 into the next.
Oh.
And then it moves them over, and then, until it fills it up.
I see.
Right.
I see.
So you end up with a 16-bit value that has 2 bytes combined together to make that 16-bit value.
I see. Okay, easy enough.
Right.
And then it sends to the terminal a 1, which remember we were talking about ASCII tables and the use of ASCII tables. A 1 is heading, so I guess I'm assuming it just goes to the beginning of the terminal
the ASCII
window.
table will say heading, but like we said last time, the parallax serial terminal,
the first 16 have
has a
functions.
special meaning, and 1 means go back to the top home position of the window, right?
Okay.
The screen.
Yep. And then it goes to the beginning. So, and then show values. That
just prints
out strings, right?
Yeah.
And that
prints out the raw X, Y, and Z values that it read out of the compass.
Right. And that's easy enough.
Sure.
So when you run this, you end up seeing your prop tool, your serial terminal, parallax serial terminal, just give you the 3 numbers for X, Y, and Z. That's it.
Just the raw data coming out of the compass, which is not really all that useful in human form. Like to you, it's not degrees or radians or anything like that. It's just units of the compass.
Speak to yourself. Speak to yourself. Yeah.
What's your computer?
But it's handy. Like you could just use those values in your code to do stuff if you wanted to.
Right.
But the other example that you have that you got off the Parallax store page, it actually does some math for you to turn it into degrees, right? So it makes a little more sense for human readable. It's 90 degrees rotated that way on the x-axis, right? Or whichever axis it happens to be.
Right. Did we want to go ahead to that portion?
Yeah. Well, unless you had more questions about this particular piece of code.
So no, I don't. And a lot of these pry functions that you guys will see here are also in the next piece of code. So I pretty much didn't touch the pry functions. I didn't touch the functions that I didn't understand, to be honest.
Yeah.
But there were
most of those are the I2C function.
Right. So I just didn't even bother worrying
Stuff
about
you
those.
really don't have any reason to change anyway.
Right. They're just the functions you use to talk to any I2C device, right? So they're just send and receive and start and stop are just the standard I2C commands that any of the modules that use the I2C protocol will use. And so it's just the same for all of them.
Right.
And they just happen to copy it into their code for these 2 demos. You can also just go download a separate I2C object and include that instead if you wanted to.
Gotcha. Oh, that's handy.
Right.
Okay. So this next spin file you can find, I believe, on the product page for the Compass module. And it's called HMC5883L_demo.spin. So this actually gives you quite a bit more information. You can get azimuth readings. You can get the heading reading. You can get the raw values just like you did before. So that's some of that is more human friendly language, like northwest 30 degrees. Like
right.
That makes more sense to people. So we'll skip looking at the.
Well, the beginning is very
pretty
similar. It has more of the commands to send over to the chip to tell it which registers and whatnot, because this program uses a little bit more in a couple places, but it also they didn't weed it out like the Kickstart is stripped down to the minimal.
Right. So I guess we'll just start from the main section, because it's besides that change, everything else is pretty much the same.
Well, there's one minor thing we should mention is that it does include a math object.
SL32. Mm-hmm.
And all that's doing is allowing you to call arctan, which uses the sine and cosine tables built into the propeller to calculate arctan for you. So that's all that math function is used for in this particular program.
Right. And I'm not too concerned about knowing exactly how that works. So unless you guys want me to go through it, I mean, we can.
No, it's
just let us know.
It's just doing arctan. You give it the X and Y component, and it gives you an angle in degrees based on that XY input.
Gotcha.
Just standard arctan.
Gotcha. All right. So the main function, we're waiting. We start the terminal. We set these measurements to go continuously like before. We set the pointer to the beginning of the book class. Then we get the raw data from the compass. Mm-hmm. Again, set the terminal little cursor to home. And then this one we are calling raw term and heading term. Raw term we know, which is just the raw XYZ data like before. Right. Heading term, however, tells you things like north or south or west and a degree along with that. Yep.
So if you're heading straight north, it'll just print north. But if you're heading a little bit northwest, it'll say like north 10W.
Right.
And it'll be your 10 degrees west, but in the northwest direction, right? And similarly, it'll have like north 10 east would mean that you're 10 degrees towards the east direction instead.
Right. And when you look at, say for heading term, since that's new to us, when we go to the function heading term itself is calling another function, heading.
Right.
So if you go down to heading, then you'll see that's like where all the math and all of those values and such are being calculated.
Yeah. And the most important function in there is that ascii adjust function, which is taking the raw XYZ values out of the compass and producing the angle in degrees around from 0 to 360 around the chip.
Right.
And it's assuming that the chip is sort of in the upright position so that you're basically going around the one axis.
Right.
So if you turn the chip sideways, this particular code wouldn't give you the right result. Right. That's one thing to be aware of.
Right. So part of this that may be intimidating for newbies is, again, looking at the code, and you'll see term.tx, parentheses, a whole bunch of numbers like 13, 13, 32, 29, 32, 13, 13, and this is all making it pretty, so to speak.
It's all just ASCII.
Right.
Yeah, it's all just ASCII. So
on
if you want to know,
computers and microcontrollers, letters aren't letters; they're actually numbers to the computer. And ASCII is an 8-bit way of representing numbers. The propeller has a built-in character map that uses ASCII to map numbers to letters.
Right.
And most of it lines up with what would be on a computer and is very standard for something like a serial terminal.
Right.
And 13 is a carriage return. Like, if you want your propeller to hit the return button on the debug window on your computer, you're looking for a character 13.
Right.
Right. And 32 is a space.
Right. So for any newbies who want to try and figure out how to finagle with the code to make it look better or to make the terminal, the serial terminal data look better, finagle with the term.tx and the number. I messed around with that, and I managed to get it to look much more concise, much more neat than what this particular code had it as. Because there are spaces all in strange places.
All right.
So
we're out of time, guys.
What?
Yep.
Already?
Yep.
Yeah.
You think we should cover this again next week?
No. I think we did a really good, thorough
Intro.
job of getting the introduction there. And if anybody has any further questions, they can send them over to feedback@tymkrs.com
I suppose.
for email, or on Twitter @tymkrs, or of course directly over to Addie or myself or Roy. Our information is all listed on the About page on firstspin.tv, which is of course where you can download this show every Tuesday.
Mm-hmm.
We usually put it in the evenings, so always for sure it's there on Wednesday. Yeah. If you don't want to pay attention to it, you can subscribe with your phone, your iPod, whatever, and it'll automatically download it for you.
Correct.
Which is handy.
Correct.
Yeah.
All right, that's my spiel for the end of this show.
That was quick. That was a very quick show.
Yeah, well, I think we've got it down pat, and when we don't have to do it 3 times in a row, it's a lot
We're
easier.
A-okay.
Yeah.
All
Sounds
right,
good.
thank you for listening, everyone. We will be back next Tuesday with another First Spin.
Bye.
Bye.
See ya.